away. Please close this thing. Here we go. See, it already says the wrong thing. Right, so just let me flip my laptop over so I can write, and let's just get straight into it. So guys, remember, I can't see the chat at this point, and my mic is not muted, so I can hear you guys. Just interrupt me if you need to. Okay, so 1.1, I'm going to try and skip through most of these because we've done a fair amount of these on video as well. So you guys have a few of these. Maybe I should just do one of these, one of the ones at the bottom, because that's probably the more difficult ones. So let's start with, let's see, maybe 1.5. That's probably the hardest one here. Okay, but now I need to make space. So let me go this side. 1.5 is here. Okay, so let's see, how can I do this? Let me just write on the side here. Okay, so this is a solve for x, if I remember correctly. Yep, solve for x if possible and check your solution. So I think we looked at cases where we can get no solution or infinitely many solutions. And I'm sure some of these here will fit that criteria. But anyway, let's just do one randomly and see what we find. So 1.5. So for 1.5, I first want to get x alone to one side. So let me make that the left-hand side. So the first thing I will do is I will move this 5x to the left-hand side to make it a positive 5x. So let me start by writing that. So on this side, we have a 7x plus 1, and there's a positive 5x because I've just moved that. And on the right-hand side, what I can do immediately is the 6 over 2, that is basically a fraction multiplied by this thing in the bracket, which is 4x plus 1 over 3 times 2. So that 6 over 2, I can consider it to be a thing by itself and simplify it by itself. 6 over 2, which will just give me 3. Right? So before I go any further, I can just write this as 3 multiplied by that entire bracket. 4x plus 1 over, and I'm just going to immediately write 3 times 2 as 6. So I've done a few things here in one go. First, I've moved the negative 5x from the right to the left. Then I've simplified the 6 over 2 in front of this weird-looking fraction. And then the 3 times 2 at the bottom of this fraction, which was on the top of another fraction, I've simplified that to 3. Okay, so again, guys, interrupt me if you need to, and please don't be afraid. Okay, so for now, I'm just going to go ahead and I'm going to write here 7x plus 5x gives me 12x on the side. There's still a plus 1 here. And on the right, I can multiply this 3 into the brackets using the FOIL method. So first, it will be 3 times 4x, which gives me 12x. Then it will be 3 times 1 over 6, which is the same as 3 over 6. Right, I could have simplified that in one go, but I don't want to skip too many steps because I can also just duplicate this entire thing and move it down and then do that step. So 3 over 6 will give me a half. Okay, and I can move the half. Yeah, let me just keep on doing this, actually. That's helpful. I can move the half to the other side. Let's make space for that. And then it should become a negative half if I move it there. Let's turn that plus into a minus. And then this just becomes 12. 1 minus half is just a half. Okay. So that becomes 12x plus a half minus 12x. I can move the 12x from that side to the side in one go. And this is going to be a weird one because 12x minus 12x just gives me 0. But let's do this slowly so we don't lose track of everything. So let me take the minus half to the other side. Keep the x's on this side. So this is going to be 0x is equal to minus half. 0x is the same as 0 because anything times 0 is 0. Equal to a half. And there was a rule here that we had to remember. So if you're trying to solve for x and you end up with something which gives you a contradiction like this, clearly this is a contradiction because 0 cannot be equal to minus half. So if we get something like this, it means there's no solution. Okay, so we did stumble upon a weird one here, but that's good. It's good to keep on seeing these things so we remember. Okay, and that was 1.5.
All right, so
Yes.
I just want to note that I don't know if there's two ways to do this. So instead of doing the way like where you went the 6/2 and you simplified it and it basically became 3, if you left it like that and then you just did the 3 times 2, the 1/3 times 2, and then you took that 6 into the brackets, could you also do that way? Because
That's perfectly fine. Yeah.
I ended up with a different answer. I basically got 2 = 1, which I mean, it's still no solution, but
Mm.
it's still got a different answer to you.
Yeah. No, that's perfectly fine. 100%. Yeah.
I think so.
Okay. Yeah, so
Uh,
guys, yeah, sorry.
I'm sorry to interrupt there. I also
No
got a
problem.
different answer. 0x = -1, which also
Mhm.
means no solution. So I don't know. Is it still the same, or what's the difference?
I
I
got
don't
that
know.
as well.
Okay, no, that's perfectly fine because when you end up with a no solution situation, these things are not unique. So I'll show you, I can reproduce anyone's solution here, right? So I have 0 minus a half. If I multiply both sides by -2, then I'll end up with 0 is equal to the 2's cancel, the minuses cancel, and I get 1. So I can recreate anything here. When you get to no solution, it's not a unique thing. So it's okay if you get different things, it's fine as long as you get something which is a contradiction, then we're on the right track because there's no unique way to get to this thing as well. So yeah, as long as you guys got that, it's perfectly fine. Okay. All right. So if there are no more queries, feel free to interrupt me again, guys, anytime. I'm just going to move this further up somewhere. We can find it another time when we need it. Okay, and now 1.5 is done. Let's see, what else should we do? We've done all of these at some point. Solve for x, plot and check. Maybe I didn't cover checking these solutions in detail, so let me do one of them to cover that. There's only two here, 2.1 and 2.2. Let's do the second one. Always, second one is probably more challenging. Okay, so solving for x with an inequality means we're going to get more than one x value, not just a unique x value like we would expect to get above in this first question. I mean, if there is a solution, that is, we get unique x values here. Here we get a range of values. So yes, a bit of recap as well. So 2.2, we will start off by, let's see, it's nice to immediately get rid of the negative sign from the left. So essentially, it depends what you prefer to look at it as. We can multiply both sides by -1 or divide both sides by -1. The result is the same. It's that the sign shifts from the left to the right. So again, that's on video in case you guys get lost with that. Those are the two things you can do. Again, sorry, I'm going to try not to waste too much time because there's a lot to get through and not a lot of time. So you guys may remember the rule. If I multiply or divide by a negative sign in an inequality, then the inequality sign changes. So greater than equal to becomes less than equal to. And then we have here 2x plus 1 over 2. And of course, there's a negative sign, which we can take to the top or the bottom. It's completely equivalent. So I'm taking to the bottom because that's just a single number. Right now, let me think for a second whether I'm making my life difficult for nothing. I could have just taken the 2 to the left. Either way will give me the same result. Okay, let's just go on like this and see what happens. I made a choice. I'll go with it. As I said, there's like infinitely many ways to do these things. So there's a 2 at the bottom here. That is the same as writing both the terms on the top over the common denominator. Right? I just split, see the top 2x over the bottom plus 1 over the bottom. Right? That's what a common denominator does. So now the 2's cancel out here and we just left with negative x. Here, this is basically just a negative half, right? It doesn't matter where that negative is. Okay, and on this side we have x. plus 2. Is this going to be another weird one that cancels? No, it's not, thankfully. Okay. So I can bring the x from the right to the left, and this becomes x plus x. I can take the 2 from the left to the right, and it becomes negative 2. Okay, so we're going to get a decent number here. I hope this is going to become 2x on the left, and this is going to become negative half minus 2. Let me just work that out on this side quickly. Negative half minus 2 is the same as negative half minus 4 over 2, right? Common denominator, and that gives me minus 1 minus 4 will give me minus 5 over 2. So that's the that's the right-hand side. Minus 5 over 2. But now there's still a 2 on the left, which I don't like, so I'll multiply. Yes, we can multiply both sides by a half here. Multiply both sides by a half to get rid of the 2, and that becomes x less than equal to minus 5 over 2 times a half, which is x less than equal to minus 5 over 4. Right? That's how multiplication works. Multiply the top, multiply the bottom separately. Okay, so that's getting the solution. Then we have to, did they say plot or check? Check, okay. Double trouble here. So let's do both. So first to plot something like this, you have to draw your number line. Actually, maybe we should make this a more digestible number, because 5 over 4 is a bit of a weird one to spot on a number line. So we can write this as a mixed fraction, that's the word, yes, or as a decimal. So that's up to you. It's always easier to go decimal if you're not sure what to do, so let me do that. Minus 5 over 4 is the same as minus 1.25. Right, so that we can spot easily on a number line. That's basically 1 1/4. Right, makes sense. Yeah. As a mixed fraction, that's what it would be. So let's draw a number line, 0, 1, 2, 3. We don't need too many numbers here because this is a small number we're dealing with. Okay, why does that keep happening? Minus 2, minus 3. And now we need to spot this number. Negative 1,25 will be somewhere here. Okay, maybe I shouldn't do that. So let's just do the proper thing in one go. Let's get our color, doesn't matter. Let's use blue. Here we will draw an, let's see, a colored in circle, because the inequality is less than or equal to, right? So if it was just less than, it's an open circle. Like this, it's a colored in circle. And then we draw an arrow in the direction of our inequality, which is that way, and show another arrow here, which lets us know the solution goes on forever. Okay, that's the plot, and now to check the solution, we need to find the original inequality to do that. Okay, so to check it, it's a two-step thing. So from here, that's the original inequality. First thing we do is we rewrite the original inequality as an equation. This is step 1 of the check. So that will be minus x plus 2. This is just a bit of a headache, but we have to do it. Is equal to 2x plus 1 over 2. And then we also write the solution as an equation. So that is x is equal to minus 5 over 4. Then you plug your solution into the inequality and check if you end up with left-hand side equals to right-hand side. So I'm just going to do the plugging in for you guys. Maybe I won't do this whole thing. Let's see. So this will be minus, and then x here is going to be minus 5 over 4 plus 2 is equal to the right-hand side is 2 into 5, negative 5 over 4, sorry, plus 1 over 2. Okay, I'm not sure if I should need to do this whole thing. But again, we just simplify to see if left-hand side equals to right-hand side. So, okay, let me just do it quickly. Let's just do this thing. I don't want to leave anyone in the dark in case anyone's not with me. So 2 can be rewritten as 4 over 8, right? So I have a common denominator here. On the right, we have, let's see, the 2 and the 4 can simplify to give me a 2 at the bottom. Right, I'm trying to do this a little bit quickly. And the 1 can be written as 2 over 2, so that's a common denominator, all divided by 2. Okay, now quick maths is going to fail me here. 8 minus 5 is 2. No, it's 3. Yeah, it's 3. 8 minus 5. There's a little negative on the outside. And we end up here with 3 over 4. Okay, on the right-hand side, is this simplifying nicely? I hope it is. Minus 4 plus 2 is minus 3 over 2, and that's all divided by 2. Okay, I think we're getting there. So this is minus 3 over 4 on this side, and on this side we have minus 3 over 2. Remember, you can change division to multiplication if you invert the second fraction. So 2 as a fraction then becomes half. Yeah, and that's going to give me minus 3 over 4. Here we have minus 3 over 4, which can be written much better than what I did. Minus 3 over 4, so left-hand side equals right-hand side. That's the first step of your check. It's a bit much for the first step because we still have another thing to do. But yeah, again, it's good to see this at least one time. Okay, and let's see. The second step is to take your original inequality, which I'm trying to remember. Did I write it somewhere? Okay. Just do it again here. So minus x plus 2 less than equal to, my memory is very short term. Already I got the wrong thing. So 2x plus 1 over 2. 2x plus 1 over 2, and this here was not correct. It's the other way. Okay, so now step 2, we need our solution as well, which was somewhere. There's it here. Let's grab that, bring it down. And let's also remember that this was equivalent to, what is it? 1 1/4, I think. Negative 1 1/4. Another way to write it. So now the thing is, we need to pick a value which satisfies this inequality. A value which satisfies this right here, our solution basically. So we need to pick a value less than or equal to minus 1/4 is what I'm saying. So what's less than minus 1/4? A nice number which is less than minus 1/4, maybe minus 2, right? Again, you can pick any number less than this, but it's nice to pick ones which will give you decent things. Don't pick something like minus 2 and 5/8 or something. Why would you do that to yourself? Just pick x is equal to minus 2. Then you plug this into the inequality and check if you end up with a true statement. So let's see if we end up here with a true statement. So plugging this in, I'll get minus 2 plus 2 on the left. That actually works out very nicely. And on the right, we will get 2 into minus 2 plus 1 over 2. So the left is going to give me a nice 0. That's helpful. The right is going to give me a minus 4 plus 1. Should I do this in one go? Yeah, let's just do it in one go. Minus 3 over 2. So is this a true statement? Is 0 greater than or equal to minus 3 over 2? Yes, it definitely is. So that's a true statement. So that's the second step of our check. Done, and we are done with this question. That was a lot for one question. Okay, so again, if you have questions, just interrupt me. Now I'm going to move all of this out of my way so we can do some more stuff. And what I need to do is make sure I get to the complex numbers before the end of the session. So let's see how far are we. We've done that. Find the domain is also a new thing. Factorize, I can live without doing that. Okay, so let's do find the domain. We haven't seen this one in the lectures just yet. So this one is as easy as you can imagine. So finding the domain means finding the allowed x values. And whenever we see a fraction, we know the bottom is not allowed to be 0. So whenever we have a fraction, we have something on top and whatever's at the bottom, I'm going to just call it g of x. G of x cannot be 0. That's our primary rule here. So the x values that are allowed are everything. So we'll write it like this. For example, if I'm doing 4.1, the allowed x values are all x values except x cannot be whatever makes this denominator 0. And we see in this case it's 3. Right? Just by inspection, we can look at it and see. Because if I plug 3 in here for x, we'll get 3 minus 3, which is 0. So it's as easy as that. The first one is just x an element of real numbers, x not equal to 3. This is always the format. You start by saying x element of real numbers, then you just exclude the x values, which make the denominator 0. Right? Simple as that. So 4.2 takes a little bit of doing because you have to know how to factorize here, and I'd recommend you guys to please look up how to factorize if you're not sure how to do it. There's a lot of videos and stuff to help you with that, and I'll try and make one as well and upload for you guys. But yeah, we might not have time. So to factor this, I can rewrite it as x plus 2. Does that work? Let's see, x squared plus... Yeah, so that works. You can write it like this, x plus 2, x plus 2. As you can imagine. And then if you use FOIL and open it up, you will get back to the original. That's a way to check. But x plus 2 is repeated here, so I can just move 1 and write it as x plus 2 squared, right? So from here, firstly, it's clear that the numerator of these fractions serves no purpose. It doesn't matter. That's why in 4.3 I made it look weird, because it doesn't matter. It doesn't change anything. We only look at the denominator. So for this, the answer here is going to be, as you can imagine, x is an element of real numbers, but x cannot be negative 2, because that's the value that makes that denominator 0. So we don't like that one. Okay, and it's going to be a similar thing here at the bottom. The bottom is kind of relying on the fact that we know how to factor 2 times, I guess. So this is going to be, the top doesn't matter. Just put a dot, dot, dot. No one cares about the top. I can pull a 4 out from here firstly and rewrite this as x squared plus 4x plus 4, which is the same thing I have above, right? So factoring it, I'll end up with the same expression. The top, we can rewrite it. It doesn't matter. The bottom here is going to be 4 into x plus 2 squared, right? We just did that one. So the domain of this is going to be exactly the same as the domain of the question above, because the only value that makes the bottom 0 is minus 2, right? That 4 in the front doesn't play a role in making it 0. Okay, so that's the domain thing. And after that, we're factorizing a few expressions, which I kind of looked at here a little bit, but okay. Solve for x. This is again relying on your ability to factor and memorize some stuff from the notes. Like 6.3, 6.4, I'll tell you guys right now, if you go to the notes, you will see things that is a formula, you kind of memorize it, how to do these ones. So I don't want to spend too much time on memorizing stuff here. You can go and look at that. It's in Learning Unit 2 in the factorization section. Just go have a look at that. And 6.1 and 6.2, okay, we have rules for that. It's called the R and S method. But also, guys, you can use your calculators to factor, and you're allowed calculators here. So I'd recommend learn how to factorize on your calculators because it saves you a lot of time, a lot of effort. And if the question doesn't ask you to show your working, then just use your calculators. It's okay. And in fact, it's unlikely for it to ask you to show your working. And if it does, all you need to do is go from this step to something of the form that is equal to 0. X plus something, x plus something. Right, in this case, what's that number going to be, just for completeness? Let me think for a second. 5 and 2, I guess. Yeah, 5 and 2. So this is all you would need to show. I mean, sorry, this is where you'd have to start for showing your working. And then, of course, you guys know this thing. Maybe, okay, let me not assume. Then you write one factor is equal to 0 or the other one is equal to 0. And then you just solve for x in both of these cases. Here you get x is equal to minus 5, x is equal to minus 2. There's your two solutions. Again, this factorization step, the first step, is the only thing you need to go and check and make sure you know how to do. But your calculator does that for you. Just make sure you can write it in this format after getting the answer from your calculator. Then that's everything you need to show. That's perfect. Okay. All right. And then express using exponents, giving us some weird questions here. How many of these are there? Simplify, okay. Okay, we also got a decent amount of time, so we can cover these without rushing too much. Express using exponents. So this relies on, I think we covered this, but I'm not sure. This relies on the fact that any power can be rewritten as, so I'll write it here, that, or any root, I should say, any root, an nth root of, I'll say a, can be rewritten as a to the power 1 over n. So that's rewriting a root as an exponent. And so knowing that, can we simplify question 7? I'm sure we can. So if I follow the rule, this will become a to the power 1 over, no, hang on. It's not that simple. There's an a cubed in the exponent. So I'll put that in brackets, and this is a square root. So technically the power being shown here is a 2, even though it's not shown. If it's a square root, it's a 2, so that becomes a half here. Okay, and this is multiplied by a to the power half with a 3 on the outside. So here exponential rules again, which we probably have covered. So this becomes a to the 3 times a half. And this here becomes a to the half times the 3. Okay, so because that's how exponential rules work, you multiply the powers if you have a bracket and then a power on the outside. So now 3 times a half, again, this is the same as 3 over 1 times a half. And multiplication with fractions is you multiply the top numbers and the bottom numbers separately. So this will just become 3 over 2. And this will just become the same thing, 3 over 2. Now exponential rules again, when you have a common base and different powers, you can write them using the common base and then just add the powers together. 3 over 2 plus 3 over 2. Okay, and these already have a common denominator, which is nice. So we can just say 3 plus 3 over 2, or just 6 over 2, which we can simplify to a cubed. Okay, is that what the question wanted? Express using exponents. Yep, that's it. That's all we need to do. Okay, and I made these, so did I make them difficult? Let's see. Okay, so simplify. This one here looks like we need to think a little bit, 8.1. So generally, if you have the same root, like for example, 2 root 3 plus 5 root 3, you can just factor out the root 3 and the numbers left basically just add together. So that's 7 root 3. So it's always helpful to rewrite things using the same base if you can. So let's see, can I rewrite 27 something? Did someone say something? Am I just tired and hallucinating at this point? Okay, anyway. Square root 27, yes, can we rewrite that as something? Can we write that as
Yeah, so you can
These-
write that as 3 to the root of 3.
3 cubed, 3 times 3 times 3, right? Yeah. Okay, so let's do that. Let's write this as 8 root 3 minus but we need to keep a square root 3 somewhere. So let's write this as 3 times 3 times 3 all square root. Okay. Plus now can 75 be rewritten somehow as 3 times something? 3 times 15? No, 3 times 25? Yeah, that will do it. So let's write this as 3 times 25. So that's the trick here. So we have root 3's all over here. So I see this going to work. So now I can explain this carefully. The first one is 8 root 3. We don't interfere with that. That's okay. Second one, we can rewrite it as 2 of the 3's. I'm saying weird things, but just bear with me. 2 of these 3's, there's 3 3's here. 2 of them we can multiply together to make a 9. And the other one we leave alone. And from here, the 25 we will leave alone. And this 3 we can also leave alone for now. Okay, now, again, because a root and an exponent are the same thing, which we've shown above somewhere here, right? A root and an exponent are the same thing, just like in a slightly different way of looking at things. So roots follow exponential rules. meaning if we have a root distributed over two things, we can then break it up and write this as root 9 multiplied by root 3, just like exponential rules. So here, root 25 times root 3. So we can simplify the first term we leave alone. Square root 9 from the second term can be written as 3. Then we're left with the root 3. Square root 25 can be written as 5, and the root 3 we leave alone. Now we can factor the root 3 out very nicely and write this as 8 minus 3 plus 5, all factored out with a root 3. And anytime if you get something like this, even though it's not difficult to do, 11, 10, right? Always use a calculator. Just always be safe with these things. Okay, so that's what we wanted.
So I've just got a question on that one, right?
Yes.
Would we be wrong if we just use our calculator from the equation? So you know how you get root at 27? If we just put that in the calculator, it'll literally just give us 3 to the root of 3. Square root of the root of 3, or however. So basically to your third last step there.
Yeah, you can do that actually. If that works, then let's do it. I mean, it may not always give you the same base like it's doing here, but actually you're right, most of the time it should. So maybe a good step is to always check first if your calculator does it for you. If it doesn't, then you can start playing around like I did. Okay, but thank you. That's helpful. Hopefully you guys heard that. That's very helpful. Use your calculators as much as possible. Don't be afraid. Okay. All right, so now we are at complex numbers. This is where things get a little bit, I was going to say complex, but that's too cliche. They get a bit strange here. It's like new stuff happening. So let me move this first and get that out the way. Don't want to see that for now. Okay. There's a few other things I'd like to do, but let's make sure we get this done so we don't have to rush for time here. Yeah, ooh, there's some deadly things here. Okay. So the first thing, complex numbers is based on this definition right here. I is equal to square root -1. Now, the whole point of complex numbers is that usually in real numbers, we ignore negative square roots because they don't have solutions. They're weird things. We don't like them. Here, we still don't like them, but we just label them as square root -1. We label it as I, sorry, and we just don't interfere with that I. We leave it alone. Sometimes if we square it, we can use it in certain ways, but for the most part, we don't interfere with it. So a complex number has this form here, usually labeled by Z. It has the form A plus BI, very important, where A is called the real part and BI is called the imaginary part. So this part we call the real part, this part we call the imaginary part. And A and B are both some integer, you could not necessarily integer, some real number actually. A and B are real, but B times I gives you an imaginary part. And this entire thing here is called a complex number. So that's the basic form. For example, 3 plus 2i, that's a complex number. Okay. And next important thing we need to learn before I do this is what's called a complex conjugate. So a complex conjugate, usually denoted by Z with a bar on top, is just A minus BI. So all you do is you flip the sign of the imaginary part. So originally what was plus BI now becomes minus BI. The imaginary part sign flips. So in this example here at the bottom, it would just be 3 minus 2i, right? The part with an I changes sign. That's all it is. That's called a complex conjugate. Now let me just, if I can spell this thing, C-O-N conjugate, J, yeah, J-U-G. Okay, no, actually I would check that. Now my brain is not working, but anyway, complex conjugate. Okay, if someone can look that up and correct me, that would be helpful, but for now I'm just going to leave it like that. Yeah, anyway, complex conjugate. And let's look at a few examples here. We need to learn how to add, subtract, multiply, and divide. So let's try and do at least one of each here. So question 9 is just to simplify these things. The first one is not really any of those. It's like a precursor to see if we know how to deal with these things. So this becomes negative. We can always rewrite a negative in a square root as -1 multiplied by the number, right? That's the same as -18. The negative on the outside, we just leave it alone since it's there. Square root of 1, I'll break this up as square root of 1, square root 18, right? We can do that. And again, there's ways to simplify square root 18, but as it was just recommended to me, use a calculator, right? It's always easier. So the calculator will give me probably 3 square root 2 with this. Let me just check. Yes, okay. So negative on the outside. The square root -1 we know is I, so I'll just put that as an I, and in front here the square root 18 just becomes 3 square root 2, and by convention it's nice to write the I on the right hand side of the number. Technically doesn't matter, but it's just by convention that we do it this way. Okay. All right, 9.2. They're trying to make things complicated here, but it's not really so bad. If you have a sum or a difference of complex numbers, all you do is you keep the real parts together and the imaginary parts together, and you deal with them almost like that imaginary part is a variable, like an x or something. So in this case here, I will break this up into, let's keep all the real parts together. I see a 1 here, right? I see it. I'll scratch them out as I go so you can see there's a 1, there's a 3, there's a 7. Let's put a 7 here. And there's an I squared. Now, I squared is what? Is that real or is it imaginary? Well, I squared is just going to be 1. I mean, sorry, -1. Because think about it, from up here, we know I is this. So if I square the I, it's like undoing the square root, right? And that just becomes -1. So I squared is -1. So I'll keep the -1 here with the real parts, because that is real. Everything else is imaginary. So let's write it over here on this side, 2I plus 3I plus 5I. And from here, it's just calculator work, right? Because the part on the left, the real numbers, you just add them together. 1 plus 3 plus 7 minus 1, and you will end up getting 10. The imaginary parts you'll end up getting, or let me just do it first. You'll say 2 plus 3 plus 5, right? And you'll end up getting 10 as well, 10I. So generally with these, you always want to end up with a form that is A plus BI, something real plus something imaginary. So we've reached that point here and we're happy with it. In fact, above, we've also reached that point. It's just that the real part was 0 here. That's okay. It's still the same form, A plus BI. Okay. Now 9.3, subtraction. So this one's not bad as well. You just have to be careful for this negative sign. Distribute in the brackets. So this is 2I minus 1. The negative distributes and becomes -1, -3I. And then it's the same story as before. You keep the real parts on one side, the -1s, and then on the other side, we will keep the -3I plus 2I. Simple to sort this out. It's -2 for the real parts and -1 for the imaginary parts. -3 plus 2. Okay, and that's the form we wanted, real plus imaginary. Doesn't matter that it's a minus, because minus can be written as, you can write this as -2 plus -I. So even if you get something like this, it's fine. That's what we want. Okay, multiplication is also not difficult. It's only division that gives us a bit of issue. So multiplication right here, this is not too bad. We'll just use the FOIL method to open the brackets up. So I'll write this in detail so we can see what's happening. 2I first multiplies by the 1. Oh, sorry, by the 1. Then 2I multiplies by 3I. Then -1 multiplies by 1. And -1 multiplies by 3I. Okay, I might be making a bit too much of this thing. You can simplify it quicker than this if you want. That's okay. So this becomes 2I times 1 is just 2I. This side we can write this 2I times 3I. The 2 and the 3 we can just immediately multiply and make a 6. Then we've got I squared. We know I squared is -1, so we'll get to that in a moment. The next term is just -1, and the next one is -3I. Okay, so doing this further, we can write it as 2i minus 6, because I squared is minus 1. 6 times minus 1 just gives you minus 6. Okay, then what's left here is minus 1 minus 3i. So now we can do the usual trick and just keep the real parts on this side and the imaginary parts on this side. The real parts will give me minus 7. The imaginary part gives me minus 3 plus 2, which is minus I. Now we have that form, so we're happy. We're done with that. Okay. Are we getting to where we want to? Yes, we are. We will make it today. That's good. Okay, 9.5 is a very similar thing, so I'm not going to do that. I'm just going to show you guys quickly what you should do. You can rewrite this as 1 over 4, bring the 4 out, and then it's just 2i minus 1 and 1 plus 3i. So bringing that 1 over 4 in front, just to show you guys it's the same thing as before, except now we've got a factor in front. So you multiply this out, you end up getting an answer. Whatever you get, then just divide every term by 4, and then that's your final answer. Okay, I'm rushing that a bit because I want to get to the last two. 9.6, I have to take a bit of time to explain because you need a trick to solve this one. Because it's clear that this is not in the form a plus bi. It's not even close. It's like a plus bi divided by a plus bi. And to get that to this form is, we have to use what we just learned about the complex conjugate. And another thing I should mention is that it's known, and we can test it, that a complex number z multiplied by its complex conjugate always ends up giving you a real number. Right? And that's a very helpful thing, because if you can get a real number at the bottom, it's kind of equivalent to 9.5. And in 9.5, we know we can get it to this form. So 9.6, let's use this trick to get the bottom to the form. So the bottom can become real if I multiply the bottom by its complex conjugate. So that's what we want to do. Let me first rewrite it as it is. I plus 1. Maybe I should rewrite this as 1 plus I. Again, we can do that just switching around. But now it's more standard. We've seen this form, a plus bi. So now to multiply the bottom by the complex conjugate, we need to multiply it by 1 minus I. Right? And mathematically, we can't just do that for nothing. We have to then multiply the top by the same thing, because then this here is equivalent to 1. So it's like we're multiplying by 1, which doesn't do anything. So that's mathematically legal. We can do that. And now that we've done this, we should be able to simplify this. It's just a matter of foiling everything out. So the top here, I'll write it as 2i minus 1, 1 minus I. The bottom is 1 plus I, 1 minus I. So let's do them both in one go. The top, I will open it up, and we end up getting 2i minus 2i squared minus 1 plus I. And the bottom, this should become something real. Let's hope it does. We get 1 minus I. This thing is failing me. Plus I minus I squared. Okay, we know the I squareds are going to become 1 at some point, so let's just get that done. So I'll rewrite this on top as 2i. Okay, let me not skip a step here. I don't want to lose anyone. Minus 2, this I squared becomes minus 1. Okay, then we got another minus 1 plus I. And the bottom, we can see the two middle terms at the bottom will cancel. Minus I plus I. Those will essentially cancel, and we're left with 1 minus I squared, which is just minus 1. So that is real at the bottom because the imaginary parts cancel. So that's very helpful. So the top is just 2i. Now the next term is minus 2 times minus 1, which is positive 2. So negative 1 here and an I. So we're starting to simplify that nicely now. And the bottom becomes 1 plus 1, or just 2. But anyway, we're just going with it slowly. So 2 minus 1, which is the middle two terms, we can just rewrite that as 1 immediately and keep it on the left. The 2i plus I, which is left, can be rewritten as plus 3i. And the bottom is just 2. So this is now similar to where we would have gotten with, where was it now? I lost it. With this example here. So if you're not sure what I meant there, what I'm doing here is a very similar thing to what we should have done there. I can rewrite this now as a half plus 3i over 2. See, that's what I meant, essentially dividing both terms by 2. Just like there, we would have divided by 4. Here we got a 2 at the bottom, so we divide by 2. And this is the thing. That's what we need. It's of the form real plus something imaginary. So that's all we need to do. Perfect. So again, this, you probably could have struggled with this only because you need to know this trick in the beginning to multiply by the complex conjugate of the denominator over the complex conjugate of the denominator, which is this part here. That's the main thing we needed to learn there. Okay, and having done that, maybe we should do one more, which is this last one at the bottom. It looks a bit messy. Let's see what happens here. Okay. So 9.7, we have I minus 1 multiplied by 2i. I'm just moving that to the top. And I'll rewrite this as 1 plus 2i. So we need to do the same trick, but first the top is looking a bit terrible, so let's do something about that. We can FOIL, as we have always been doing. We can multiply the 2i into the brackets, and this becomes, first it will go here, and we get 2i squared, then it goes here, and we get minus 2i, still over 1 plus 2i. Okay, so then we end up getting, remember I squared is just negative 1, so I'm just writing that immediately as negative 2 minus 2i on the top, and the bottom is 1 plus 2i. Now we know we need to do our trick. So the trick here is multiply by the complex conjugate of the denominator, 1 minus 2i, and we do the same on top. So remember, just switch the sign of the imaginary part. And maybe let's bring this here away from all the other work we've done, so we have space to work. Okay, so again, let's use the trick since we can do it. Just copy and paste. And now we need to basically FOIL this thing out. I mean, if you wanted to, you could factor out a negative 2 on top before you do this, and maybe we should do that. If I factor a negative 2 out, this becomes 1 plus I on top. Right, if we multiply the 2 in, we can see we end up back with what we started with. So that makes my life a bit easier. And I just put brackets here to show that it's all multiplication. So now I can FOIL out the top and essentially don't worry about the 2. We can just leave it there as a factor and deal with it later. So 1 plus I, 1 minus 2i. We end up getting 1 minus 2i plus I minus 2i squared. 2i squared. Did I do that right? 1 minus 2i plus I. Yep, that's fine. On the bottom, we end up getting 1 minus 2i plus 2i minus 4i squared. Yep, that's right. Okay. So now I'm going to try not to waste too much time because we only have 6 minutes left. Minus 2 on the top. Okay. 1 minus 2i. Maybe I can simplify these two in one go. These two middle terms here. Minus 2i plus I. I'll write that immediately as minus I. And then the last term here is just minus 2i squared. Why does this keep happening? As I'm saying, the last term is minus 2i squared, which is minus 2 with a minus 1. The bottom, the middle terms cancel out as they always do with complex conjugates, and we end up with 1 minus 4 with a minus 1 because I squared becomes minus 1. So now minus 2 on the outside, 1 minus I plus 2. Here we have 1 plus 4. Okay, so we're getting there. Still minus 2 on the outside. We have here 1 plus 2, which is 3 minus I. And the bottom here we have 5, which is not such a nice number, but anyway, we can work with it. So now this is the same as saying minus 2 over 5 into 3 minus I. And you could leave it like this if you wanted to. Right? That's actually perfectly acceptable. If you want to show it explicitly as A plus BI without factoring anything out, then you just take this minus 2 over 5 times 3 plus 2 over 5i. So on the left, we get minus 6 over 5 plus 2 over 5i. Okay, so either one of these two is fine. I will accept either one. No problem there. Okay, guys, and we have like the last 4 minutes here. So do we have any questions or any example that I didn't do that you want to see done? Yeah, I think you have the ICE task if you want to browse through that a little bit. If I go over time, I'm fine with it. But any particular example here that you guys want to see done, let me just check the chat if anyone said anything. Okay, I think everyone's okay. 3.1, okay. Yes, Jared, let's do 3.1. Where was 3.1? Okay. Oh, that looks like a terrible one. No wonder. Okay, let's see what we get here. Solve and plot. Solve and plot. I don't think we can plot something like this. Okay, so let's just solve it because it's not an inequality, so there's nothing to plot. So for inequalities, I'm saying it wrong. For absolute values, we will need to isolate the absolute value alone on one side, as always. So I'll rewrite this. First term I'll leave alone. I don't interfere with it. The 26 I'll move to that side. Now the absolute value part stays the same. We don't interfere with it. We can multiply both sides by 2 to get rid of the half in front. All right, so the half will cancel out here. We're left with only the absolute value part. And let's see if my head will work now. 52, right? Yeah, 52. And this is the main point where we can then actually do finding the solution. So for this, we find the positive and negative version of the solution. Once we do that, then we can solve for x for the positive and negative version separately and get two solutions. So the positive version is easy. It's where you just take everything exactly as it is, but just don't write the absolute value part. Right? That gives you your first equation. Second equation comes from taking the negative version, which is just writing a negative sign for the absolute value part, and everything else remains the same. Right? So the negative sign only covers the absolute value part, and the brackets are rewritten as normal brackets. That's the negative part. Okay, so both of these are equations we can in principle solve. So let's do both of them. The one on the left looks easier, so we do that first. So we get 2x is equal to 52 plus 4, which gives me 56. Okay, so x is going to be, oh, that's not good. X is going to be 56 divided by 2, because I just divide both sides by 2 to get rid of the 2 from the left. So that's 15, 16, 17, 18. That's the first solution. Okay, and the one on the right, first thing we should do is we can multiply both sides by negative, or we can distribute the negative in. That's a thing of preference, up to you. I would prefer to just move the negative to the other side by multiplying both sides by -1. Then we can write this now as 2x is equal to negative 52 minus 4, which is going to be
Sorry, so you forgot about the -4.
Yeah, don't you keep the -4?
The -4.
Yeah, at the top there, you forgot to, like, the absolute value was a -4 plus 2x.
Here I see -4 plus 2x.
So on the negative side, the right-hand side, so you've got negative brackets plus 4 plus 2x. It's supposed to be a -4 there.
Oh, sorry. Okay. No, I get you. Thank you. Okay.
And then also, so 56 divided by 2 is 28, isn't it?
Yes. It's not 18, it's 28. Thank you. Sorry, guys. It's been a day and my brain is just stopping to to function. But okay, it's okay. We will get through this. So -4. So does that change much? I hope not. -4 on that side becomes now +4 on this side, and I'm going to put this in my calculator because things are not going well. So this is 56. Is that right?
No, so it's -48.
My calculator. Oh, thank you. Thanks. Yeah.
We understand, so it has been a very long day. I'm not gonna lie.
Thank you. Thank you. Okay. Yeah. Oh my God. How could I think that'll give me a positive number? Anyway, x is equal to, this one I can do in my head, 24. Yeah. -24. Negative important. Okay. So there's our two solutions. Again, just the last one I did, please just double check everything because it's possible I made other mistakes. But other than that, I think we've covered a good amount of content here. And if it was too much for you, my apologies, but everything's on video, so go back, slow it down if you need to. And yes, please ask questions if you need to in the WhatsApp chat, but sometimes there's a lot of stuff there, so I might miss something. If you need to emphasize something, please ask it again if it gets lost somewhere in the chat.
So then how would we plot this one? Because that's where I'm getting confused, is plotting it. Because I just drew circles on a graph. That's literally all I did.
Yeah, that's what you would do. I mean, they wouldn't ask you to plot something like this, so that's probably a typo there. Actually, that is definitely a typo, but I'm sure you did something like this, -24, 28, and you just put a circle there. That's perfectly fine.
So do we just put a normal circle, or do we color it in? Because I mean, it does have the equal sign. So that's that's where I'm getting totally confused. I think I sat here for 10 minutes just trying to understand how to draw it.
Yeah, let me think for a second. Actually, you would color it in if it's equal to. So you have to, because that's an inclusive circle now. It includes the value.
Okay, thank you so much, sir.
Okay.
Clarified my mind, yeah.
All right, thanks. Okay, guys, thank you for bearing with me through all the ups and downs, mistakes, and everything. And if there's any questions, I'm still here for another 10 to 15 minutes. Otherwise, I set you guys free. Go have a good supper and whatever you're doing. And I'll see you guys next week.
So I do see in the chat someone has asked for 8.2.
8.2.
Yes.
Okay, yes, I can do that. So if anyone wants to stay, you're welcome to stay for that. But yeah, you guys are technically set free now. I don't want to keep you over time. In the meantime, let me do 8.2. Oh, it looks like a demon of a question. No wonder you asked me. Okay. Let's see if my brain will let me do this one. I'm sure it will. So let me first write this somewhere where I can move it somewhere where we can work. So it's y into the cubed root of x to the 4y. Close that. X cubed root of x, y, 4. Now let's just move this further this way so we can work. And the question is just to simplify, if I remember correctly. Was that? Yeah, simplify. Okay. So usually with these, we've been trying to factor out some kind of common root. And I guess this will be no different. It's a cube root, but they are both cube roots. So that's already something probably helpful. If I saw 1 cube and 1 to the power 5, or rather a fifth root, I'll start panicking. But this might be doable. So let's see. From here, the only thing I see common in these because that I can factor is the cube root of xy. So, okay, let me not jump ahead. Let me do it like this. I'll write this as x times y, because I think that's going to be common. And I'll write a leftover here times x to the 3. So I'm just rewriting the first term in a way where I can start seeing if I have a factor to pull out. The second term, I will do the same thing. I'll rewrite this as, I'm suspecting xy is common, so I'll write it as xy multiplied by y cubed. Is that the same as the top? It's a cube root, sorry. Xy. Yeah, so I've already found something common, which is xy. And let me rewrite this as y. Now I can write this as xy, and then another cube root here with x cubed, which is just the leftover from that. And here I'll do the same thing. I'll pull out the cube root of xy, and the leftover here is the cube root of y cubed. Now that's quite nice because these are going to simplify nicely. But before I simplify anything, let me pull out what's common. That is the cube root of xy, and I'll leave here what's left as a y on the outside, and then we've got a cube root of x cubed, which we can simplify. What's left on the right after I pull that out is just x, and then the cube root of y cubed. Okay, I hope I didn't stop the recording already. I don't think I did. Okay. Yeah, so yeah, it is what I think this stays as it is. On the inside, cube root of x cubed is just x. And here, cube root of y cubed is just y. So these now become the same thing, which means I can write this as cube root xy. Add these together and you just get 2xy. Right, so I could pull the 2 to the front if I want the numbers there. This is just reordering at this point. xy. Okay, so please tell me I didn't stop the recording. Is it still happening? Okay, I didn't stop it yet. Okay. Okay, so that's that. At least that's on the recording. That's a bit of a thinker, that one, just to see what to pull out as a factor because they all look so blended together in the beginning. Let's just check if there's any more requests here. Yes, I could do that. I'll have to make one first. So at least a good amount of it is done here. And I'll just try to add to this everything else. Okay, yeah. I'll try to find time though, guys. So just give me at least, so the stuff is not coming out in the test. Give me a week or two to find time for this because as you guys know, I'm also a student and after this I have to do my own work as well. So it takes up some time, but I will get to it. I will get it done. Okay. Okay, so I'm going to just hang back for a few more minutes in case anybody else needs me. Otherwise, yeah, have a good evening, guys. It's always a pleasure.
Hi, sir. Do you mind if I just have a look again at 9.7's answer?
No problem. Where did I do this one? Oh, 9.7 is at this one here. Yeah. -6/5. Sorry, my writing is very bad here. That's 2/5i.
There we go. So, thank you so much. Good evening, guys.
Problem. Good evening.